going to go over our last section here. So we're talking about base E and natural logs. Okay, so like pi in the square root of 2, the number E is an irrational number. Okay, so E is still just a number. Okay, it's not a variable, it's a number. Shh. Let's focus, please. The value of E is 2.71828 and then so on. So it keeps going and going and going. It is referred to as the natural base E. An exponential function with base E is called a natural base exponential function. Okay, so the function e to the x power is used to model continuous exponential growth. The function f of x equals e to the negative x is used to model continuous exponential decay. The inverse of a natural base exponential function is the natural logarithm. This logarithm can be written as log base e of x, but is more often abbreviated as ln of x. Okay, so log base e, okay, is written as ln, which is natural log. So you have your exponential growth here. You have your e to the x function. Okay, its inverse is ln of x. This one is exponential decay. Okay, e to the negative x, and its inverse, negative ln of x. So you can write an equivalent base e exponential equation for a natural logarithmic equation by using the fact that ln of x equals log base e of x. Okay, so if I have natural log of 4 is equal to x, if you bring in base e, okay, if I bring in base e to both sides of that equation, it cancels out your natural log in the e. Okay, so you can end up with e to the x is equal to 4. Close the door. I don't know. Okay, so the reason we can bring in e, okay, it cancels out your natural log, which again is this log base e. Okay, so since your base is e, you can bring in a base e to cancel it out. So you can also write an equivalent natural logarithm equation for a natural base e exponential equation. So this time if you have e to the x equals 12, to change it into a logarithmic, you can bring in natural log to both sides. Okay, when I do that, that natural log and that e cancels out, and you're left with the natural log of 12 equals x. Okay, so in our first example here for a and b, we want to write each exponential equation in logarithmic form. So since I have e to the x equals 8, we need to do that inverse. So we want to bring in a natural log to both sides. So that's ln. So that cancels out with your e. So you would end up with x is equal to the natural log of 8 as your logarithmic form. And that does make it easier to solve. But we're just writing it in logarithmic form, we're not solving. For letter B, we want to do the same thing here. Okay, so we have an exponential. Since it's e, we bring in the natural log instead of log base like 5, like we were doing before. We want to take the inverse of e, and that's the natural log, so it cancels out. So we have 5 is equal to the natural log of x. Questions?
No.
We're good? Can I go move on?
No.
I have everything.
All right. So example 2 then, we're going to do the opposite. So now it's written as a logarithmic equation, and we want to put it in exponential form. So if you see an ln, or natural log, its inverse would then be e. So we're going to bring in base e to each of these. Okay, so I would have base e. On the left, that e and the natural log cancel out. So you end up with x is roughly e raised to the 0.7741 power. Okay, same thing for b.
Yeah, somebody's like balming down there.
That's why I closed the door.
Who?
Oh.
All right. So what should I do for letter B? What should I do? How do I change that to an exponential? Bring in base e. Okay, e and your natural log cancel out. So you have 10 is equal to e to the x power. And circle the last one. Okay, so it's basically the same thing we were doing before when we were bringing in log base 2, log base 5, stuff like that to cancel things out, or bringing in base 2 or base 7, whatever. But now if you have natural log, you bring in base e, or if you have base e, you can bring in natural log to cancel those out. All right, so the properties of logarithms you learned in 7.5 also apply to the natural logarithms. So the logarithmic expressions below can be simplified into a single logarithmic term. Okay, so right now we have these properties of logarithms. Okay, so when we had subtraction of logarithms, what did that went with division. If we had addition of logarithms, that went with multiplication. Okay, so that's what we want to use with our natural logarithms here as well. Now, if I have a number out front, where should that go? If I have a number out front, using my properties of logarithms, where could that go? Do you remember? You can create that exponent. Okay, so here I would end up with natural log of 10 to the third power minus natural log of 8. Okay, now before we said that subtraction makes it division. So I would have the natural log of 10 cubed divided by 8. Okay, 10 cubed is 1,000 divided by 8. One thousand divided by 8 is 125. Now, I'm okay if you leave it like that. However, I can simplify this a little bit more. So I know 125 is 5 raised to the third power. Okay, so I could write this as natural log of 5 to the third power. Now, if I have an exponent here, where could that go? Outside. So I could bring it back out front. So I would have 3 times the natural log of 5. Okay, so I'm okay if you leave it this way, but you can simplify it more to get it here. All right, we'll do another example here.
Yeah. Better.
So I have natural log of 40 plus 2 times the natural log of 1/2 plus the natural log of x. Okay, I have this 2 out front. So my first step here is to make that an exponent. Okay, so I have the natural log of 40 plus the natural log of 1/2 squared plus the natural log of x. Okay, I want to square 1/2. So I have the natural log of 40 plus the natural log of 1/4, okay, because I squared 1/2, plus the natural log of x. Now, like I said before, when you have addition, we change that to multiplication, okay, to combine all of those natural logs. So we would have the natural log of 40 times 1/4 times x. Okay, so I'd multiply all 3 of those together. So I can multiply 40 and 1/4. What do you get?
40 and 1/4.
Multiply them. What's a fourth of 40?
10.
So my simplified term here would be the natural log of 10x. Okay, so I just had to get it to a single logarithm. Okay, this is a single logarithm. This is a single logarithm. Okay, questions on that? Now you can verify your solution with a calculator. So if you have a calculator, you do have a natural log button on your calculator.
Yeah.
The one that says ln. So I can plug in this entire quantity and get a number. Okay, so if I do 3 natural log of 10 minus the natural log of 8, okay, I get about 4.828. Okay, 4.828. If I plug in 3 natural log of 5, I get 4.828. So you can check your answer. So you can plug in this entire quantity and then make sure your final answer is the same. Okay, if your answer is the same, you did it correctly. If your answer changes somehow, that means you did something incorrect within your work. For ones like this where you have an x, what I would do is just plug in a number for x in your original and plug in that same number here to make sure it's the same. Okay? And again, your natural log button is right underneath your log button. Okay, so we used log before. Natural log is right under that. All right, so because the natural base and natural log are inverse functions, they can be used to undo or eliminate each other. So if you see something like this, e raised to the natural log of x, okay, that e and that ln there cancel each other out. Okay, and if I have the natural log of e, that also cancels each other out. Okay, so they undo each other. So if you have an e raised to the natural log of x, cancels, or natural log of e, cancels. Okay, so they do eliminate each other.